Okay, so thank you all for joining me today. We're doing a webinar today, part of our regular series, approximately once a month. We'll do these sessions, but this is on pretty much as complicated a model as you can build in TreeAge Pro. So this may be beyond what you need to do, but we'd like to build features for points where you may actually find yourself in a situation where you have to do something really complicated, and we want to have the tool that's there for you when you need it. So what we're going to do now is we're going to focus on a model where we need to run patients through the model for one reason or another. But more importantly, in this particular case, we need to run those patients through at the same time. And why would we need to do that? We need to do that when the patients have an impact on each other, right? If patients disease progression is completely independent, then we can send one patient through and the next patient through and the next patient through and just add them all up at the end to figure out what our best decisions are. But when there's actual interaction amongst the patients in the simulation, that's no longer a reasonable way to approach it. We can't handle a a situation like this where we're going to use constraints, but any situation where there's interaction among the patients, if we don't synchronize them with time, so they're all passing through the model at the same time. So specifically, we're going to use this technique on a model where there's a resource constraint. And that would be just one example where patients would have to go through the model at the same time. Okay, and we'll get right into the model. So the model we're using is in your projects view. You have it with you, with your software. It's under example models, healthcare. Down here, we're using parallel trials, Q global trackers. That's the model we're looking at. Now, I've made a couple of adjustments to just hide a little bit of the text so we can look at the structure. I'll bring some of the text back as we examine it more closely. So in this particular model, it's generally speaking a Markov model, a simulation Markov model with two strategies. And the first strategy has two resources available that are constrained resource. And what they specifically are is treatment spots. So we can only have two people in treatment at a specific time. Imagine it's something like a hospital bed or some kind of specialized patient center. And we have two spots in this strategy, and this is a clone of the first strategy, but in this one we have three spots. And the people are going to pass into and through this model. If they get sick, they're going to try to get this resource, but because there's a constraint on that resource, everyone can't go into treatment at the same time as they would in a more typical model. So we're trying to mimic a scenario where we have more demand for the resources than we have resources available. And that's what this model is going to do. And let's spend a little more time looking at the structure here. So we see we have healthy, sick, waiting for treatment. In treatment, that's where the resources are taken, recovered and immune and dead. So those are our health states. Nothing different about that than a typical Markov or simulation model. But what's really quite different is that when people get sick, so here they go from healthy to get sick, or when they're already sick, we have this stop node. And you've probably never seen a stop node before. But this stop node is a point where we're basically going to send patients, and they're going to have to figure out, well, I mean, they won't figure out themselves, but the model will define whether that individual gets the resource or has to wait for the available resource. And if they get the resource, then they're going to pop down in here and they'll be holding on to that resource. They're in treatment. And if they don't get the resource, then they're going to be set to this sick waiting for treatment until a resource becomes available for that person. So you could think of it as some kind of like hospital queue or something like that, where there just aren't enough spaces to handle all the people who are demanding them. So whether they get sick right away and need the resource, or whether they're already sick and need the resource, they may still be stuck in, let's say, a virtual queue, waiting for resources to become available to them. Okay, now we need to look a little deeper into the model in order to understand how it runs. Okay, so let's look a little bit more at the stop node. So what is the purpose of a stop node here and here? Well, the stop node gives us the ability to basically stop a patient halfway through the cycle so we can see whether a resource is available to them before we allow the cycle to finish. So just imagine that there's two patients and one resource available. And one person has the resource and the other one is sick waiting for the resource. We want the ability for this person who already has a resource to potentially release it, either by becoming immune or dying, before we want to give up on the person waiting for the resource having the opportunity to take that resource. So because cycles in a Markov model proceed kind of in a direct synchronous manner, we want to give the opportunity for the people who have the resource to release it before we give up on all the people waiting for the resources to have a chance to get it. So this stop node it's almost like a breaking point mid-cycle where we can wait. Those people will wait. Everyone else will finish their cycle, including the people who already have the resource, who may or may not release it. And then we're going to release these people to then continue through their cycle, where the environment for the entire patient population has been adjusted to understand how many resources are available for the people who are waiting for it. So a person who starts healthy, gets sick, will wait here until everyone who's going to wait is waiting, and everyone else who's not going to wait is finished with their cycle. And then if there's, let's say, 5 or 6 people waiting for the resource, we have an opportunity to decide which of those 5 or 6 people get the resource. Let's say 6 people, 2 people get it, 4 don't. 2 people will come down here in treatment because they get the resource, and 2 people will go down here to sick waiting for treatment. They won't get the resource. And maybe those people would get it the next cycle, or the cycle after that, or the cycle after that. So that's what the stop node allows you to do in the model, is to create a semi-asynchronous path to allow people to wait for resources to be released and then continue through their cycle. So that's what the stop node is doing. Okay, now that's not the only important part of the model that allows us to function as we want. The second one is called the second critical piece is the global trackers. And before I talk about the global trackers, I'm going to go back into the tree preferences, and I'm going to turn on display of some of the additional numerical entries in the model, which I'd hidden so that we could see more of the structure. Okay, so now I really want to talk right now about this concept of the global tracker right here. And I have one single global tracker starting at 0. And basically that global tracker, it's similar to but different from a regular tracker by patient. But the global tracker is accessible both for read and write to everyone in that strategy. So it's more of an environmental variable that affects the whole environment of all the people, the entire cohort of people in the model, as opposed to a regular tracker, which is just about one person and the data associated with that one person. So by having a global tracker available to us, what that's doing is that's creating an environmental level variable. In this case, it's how many resources are available right now. And this number of resources available right now needs to be decreased when someone takes the resource, and it needs to be incremented when someone releases that resource. So let's take a look at what happens when somebody is stuck here waiting for treatment. Well, the first thing we do is we have a logical expression that says, are there any resources available? Well, if there are, then they get the resource. If they're not, then they don't get the resource. So this is a critical expression right here that's looking at the environment that affects all the patients and saying, is there a resource available for me? Yes or no? Okay, and a few people will go this way, depending on how many resources there are, and most of the other people are going to come down here and say there's nothing left. Okay, and so that's one place where the global tracker, or that environmental level variable, is critical. Now, that's not the only place. We also have to look at places where they get the resource. So right here is where we get the resource. So this global track that gets the value of the resource. That's the name of the resource, or that's the name of the global tracker. This T-action tracker modification is basically incrementing the same global tracker by a -1. So it's saying, if there were 2 resources available and I got one, now there's only 1 available. If there was only 1 available and I took one, now there's 0 available, and everyone else is going to have to come down here. So we need to read the global tracker to see whether there's a resource available for that person. And if there is, we have to decrement the number of resources that are available, the environment for everyone else. Okay? Now, down here is exactly the same thing. Whether you're new sick or old or existing sick, it's the same exact thing. So we don't need to go through that. But what we do need to go through down here is these are the people who already have the resource. And if they finish the treatment or die, in either case, they have to release the resource. So in other words, they're going to increment the number of available resources to the rest of the people. So going back to the beginning in terms of how people are going to flow through this model, and let me minimize some of this to give you more space. As people get sick, in strategy one, there's only 2 available. The first 2 people who or in fact, I don't have any priority in order. It's just trial number. In this model, it's just the lower trial numbers get it before the higher trial numbers. So the lower trial numbers will get the first 2 resources, or this way, everyone else will have to wait. And no one else is going to get a resource until one of those 2 people releases that resource, and then more people will get it. So I'm not asking you to believe me that this is all going to work. We need to run this model and make sure that it's doing exactly what I'm saying it's doing. Otherwise, you shouldn't believe me. We're going to check it out for ourselves. So when it's time to run this model, I'm going to go back to the root node, and I'm going to run microsimulation. And we're going to see a couple of slightly different options than we've seen before. The first is that what I want to look at is this run parallel dynamic trials. This will default to on because you have stop nodes in the model. As soon as it has stop nodes, the software will know you need to run these trials together. So you shouldn't have to check this, but you definitely need to run the trials together. Okay? This sum, average sum, this is, do I want to report back the average values per patient or the sum of all the patients? And if I were doing decision analysis, I would probably use average, but because I'm really more focused on the flow of data through the model, I'm going to use sum. So when I look at my reporting, I'm going to see counts of patients. I'm going to see integer number of patients in this model, as opposed to everything looking like fractions in different states. So I'm choosing to do sum because it'll make it easier for us to see and understand the output. And then the final thing I want to look at down here is this run trial sets. We're actually going to run only 30 people, and 30 people relative to 2 resources, or 30 people relative to 3 resources based on the 2 strategies. If in a regular microsimulation model, you would never run only 30 patients, right? You could never get stable, accurate mean values for decision analysis out of 30 patients. So you might say, you know what, I'm going to run for 300,000 or 30,000. But if I did that, that would completely throw off the relationship between the number of patients and the number of resources. Like, it's not reasonable to expect 30,000 people to get through 2 resource constraint. So I need to keep it at 30 to create the proper relationship between the 30 people and the 2 resources. But in order to get stable results, what I can do is I can run this, let's say, 1,000 times, and then I would get stable means without disturbing the relationship between the size of the cohort and the resources available to that cohort. So this running trial sets allows us to maintain this relationship, but still run it enough times so that we can feel comfortable that we have stable results. Now, I'm not trying to do any publishing here, so I'm not really too concerned with my results being perfect. I just want to be able to show you how this works. So I'm not going to use the trial sets right now, but that's what you would do in the future if you wanted to really, it was important to use a specific cohort size in order to get valid results. So I'm all ready to run. 30 people, reporting sums, running them parallel. I click begin. The model starts to run. And we're going to come back and look at this console output in a little while. But the first thing I want to look at is the time reporting. And let me just check if there's any questions before I continue. Nope, no questions. What I didn't show you, what I meant to show you, is in tree preferences on the model, I have it set up down here to use the time reporting to record all the steps that these individuals take through the model. So I can look at their patient pathways when I'm done. So that was already established and set up. So when I look at my model, my output, I can go to time reports and I can look. I'm going to focus on the first strategy, the treatment two, or two resources, and I can look at what happened to the patients. And if I look at what happened to the patients, right now I'm just looking at the first of 30 patients. And if I can slide around and look at different patients. But let's just look at trial number one. What happened to them? Well, they were healthy. That person was healthy and finally got sick and then immediately got the resource. Okay, great. This guy was lucky. He got the resource quickly. And then that person stayed in treatment, held the resource, and eventually became immune and released that treatment resource. But not everyone is going to be so fortunate as to get the resource right away. Let's look at, let's say, trial 5 instead of trial 1, or trial 10. Let me look at 10 first instead. Trial 10 was healthy for a while and then got sick, but there were no resources available for him. Right? It got sick, had to wait. Stayed sick, still had to wait. Finally, in his third cycle of being sick, that person got the resource. And then, similar to the trial, the first person stayed in treatment for a while and then eventually became immune and released the resource back. So I'm just looking at individual patient pathways to validate that the kinds of things that I expected to happen are happening. And that's what I can see through these individual patient pathways. Now, time reporting is not limited in a microsimulation environment to just being individual patient pathways. I can also generate a cohort level report here that shows me the general flow of all the patients through the model. This is the almost exact equivalent of running a Markov cohort analysis report on a Markov model as opposed to a simulation model. So this is an important part of the software. It says you need visibility into the patient flows even if you're running patients through individually rather than cohort analysis. So now I can see when I enter the model, sure enough, everybody was healthy. And then here, right, 5 people must have gotten sick in the first cycle. Because by the time I get down to the beginning of the second cycle, there's 5 people sick, 3 waiting for the resource and 2 getting the resource. And I can dig a little deeper and see, okay, 5 people got sick, 2 of them got the resource and 3 of them didn't. That's exactly what I wanted to have happen, right? I had 2 resources available, and regardless of how many people get sick, I've only got 2 treatment spots, right? So I should never, ever see this, the number of people in the holding resource go past 2, and you never do. And I can see that graphically by looking at the state prob report. And this is why I did it based on sums rather than percentages, so we could see the patient counts. And you can see this orange line, that's the in treatment. And sure enough, we start with no one in treatment, then we have 2 people in treatment, and then finally everyone's done. And everyone's been through treatment, then we don't need any of those treatment spots anymore. Meanwhile, the queue, what's the queue? The queue is the people who are sick waiting for treatment. That queue goes up and stays stable for a while and then goes down. And then it's 0 because everyone that's ever going to get treated has already been treated. So it's just a graphical way of seeing the same thing that we saw before in the report. Any question? I'm just going to check and see if there's any questions. No questions so far. And then there's one other thing I really wanted to show you that I've implemented into this model. I'm just going to close these 2 reports and go back to the model. And what flashed on the screen before, but we didn't really look at, was this console. And I want to tell you 2 things about the console. First of all, how did I get data in here? And then after I got data in here, what does it tell us? Okay, so the way I got data into that console is I specifically created, manually created output to write this information as individuals reach different important parts of the model. Now I have that tracker hidden right now, but I'm going to unhide it. There's a tracker property, this one called tdebug, which I've hidden. But if I now look at it, you see that I show someone right here. Every place you see this purple, right? That's a debug, and every single one of them uses this debug right force to tell me something about what's happening in the model. So what are my important things? I wanted to know when someone got sick and was waiting for a resource. I wanted to know whether when each one of those people either got the resource or didn't get the resource. The exact same thing down here. People waiting at a different spot. Did they get it or not? And then I also wanted to know if people had the resource, did they release it for either of these two reasons? So I've created my own customized debug output trail to be able to follow the patients as they're passing through the model. Now, and you'll notice that the text or the syntax here is debug write force. That means write stuff to the console. Model transition releasing resource. That's just raw text. And then the stage counter here, I just put it in a string, convert it to a string. This is my stage counter. And then this is my trial number. Let's see what we see in the console. First, I got strategy 1, and at stage 0, these 5 people got sick. And because I didn't apply any priority order, the first 2 got the resource, the other 3 didn't. Okay? Now we go down further, and you see people stopping and waiting for resources. This guy releasing the resource, but we don't check to see who got the resource until after the stop node and after the releases. We know there was one release, and so the one person from the queue was able to get that resource. And you could follow that pattern down to the next one, right? One person released, that means there was one person that could get it, everyone else had to wait. Here, nobody released. So everybody that got sick was still waiting. Go down. Now this time we had 2 resources released in this cycle. 2 people got the resources. Everyone else had to wait. So this output that I created was very helpful in me understanding that the model was doing exactly what I expected it to at the right time, synchronized with the other patients. And so I think, you should feel comfortable using just any tracker to write output to the console that helps you understand how your model is proceeding. And most models, you won't need that. But for a model as complicated as this, there's good reasons to create that kind of output trail to validate the model flows appropriately. So that brings me to the end of what I was going to talk about today. So I just want to see if there are any other questions. Any questions from anyone? It's not too late to ask a question. Okay, well, if there's no questions, I will replace either this recording. We did this presentation 3 times, so one of the 3 we will place up on the website, so you can look at it anytime in the future. And please don't hesitate to come here to the webinars and sign up for another one, because we'll keep adding new ones, and we'll do it approximately every month or so. I have a question here. How do you change the order of who gets the resource? That's a little bit tricky. There is a model that's almost ready to do that, but in essence, if you wanted to change the order, let's say you had some kind of priority, right? Let's say sicker people get it earlier than less sick people, and you had maybe a distribution that derived the likely or the sickness score of some kind. You would really need to write a little Python code, a little Python program that went through all those people waiting each cycle, and we have a place where you can put that, and it would have to go through, and it would read through everyone, score them, sort them, and say person, let's say 26 and person 29 get the resource, everyone else has to wait. So it would make this more complicated, but certainly not impossible. There is a model, this one right here, this Python one, that actually has a Python function in here. Allocate resources. And there's a Python function here that you write that goes through all the patients and decides who's going to get the resource. So you see, now you're getting a little more complicated than what I wanted to cover today. So, but this code would go through, and this one still just does it in the order of the patients. But this is where you'd start if you wanted to do some kind of prioritization, where it reads in the patient data and it can sort them and then decide in the order that it wants who should get it. It's just a little bit beyond the scope of what we can get through today. Let me just see if there's any other questions. Okay. I guess that's it for today. So I'm gonna close the meeting, but I want to thank you all for joining us, and please feel free to come and join us again for a future webinar.